Whenever we walk into a room to talk about climate change, we recognize that we do not walk in alone. We walk in with three 800-pound gorillas with us. And the first 800-pound gorilla is the fact that we all know that the climate has always been changing due to natural causes. We've had ice ages, we've had crocodiles in the Arctic, but this time scientists say it's different. That man is triggering this change after a period of remarkable stability. And we are doing it at a time when there are 7 billion of us on the planet, close to 10 billion projected by mid-century. And we can't just pick up our lean-tos and follow the food and water resources as they react to a changing climate. The second 800-pound gorilla in the room with us is the fact that fossil fuels have been incredible friends to us. Before we discovered them, our lives were short and brutal. They have given us a vibrant economy and a very high quality of life. But, scientists say, if we continue to use them the way we have in the past, they will begin to do the opposite, actually decrease our GDP and lower the quality of life, especially for our kids and our grandkids. And the third 800-pound gorilla in the room with us is that this is a tough topic to talk about. Perhaps it is banned from your Thanksgiving table. It was from mine for many years. But it hasn't always been thus. George W. Bush proposed a cap-and-trade approach to solve climate change in his first year of office. There were multiple bipartisan bills introduced to Congress every single year. In 2007, the Republican Congressman Newt Gingrich did a commercial supporting cap-and-trade with Nancy Pelosi. And in 2008, it was on the presidential platforms of both parties. Different ways of addressing it, but agreeing that it needed to be addressed. So what happened? Well, scientists who were active during that period tell us that when Al Gore won the Nobel Peace Prize for his movie on climate change, An Inconvenient Truth, it was a watershed moment. Something that had begrudging acceptance across the aisle suddenly became labeled as a liberal issue. And we had a new litmus test for what made a good liberal or a good conservative. And the news media didn't help. Many on the far left began to say that we needed to be anti-cow, anti-car, and anti-capitalist in order to address climate change. And on the right, they really began to cover it more as a culture war issue instead of a scientific issue. Research shows that Fox News in 2006 had about 50% of their coverage saying that climate change was real and posed problems. By 2009, 90% said it was a hoax. So we had a real hardening across party lines. But if you fast forward to today, the vast majority of Americans understand climate change is happening. A strong majority understand that it is being influenced by man. But what Americans across the spectrum report is that they do not understand how climate change will impact them personally, nor why there is urgency to address it. And that is what this presentation is meant to address. Now, we are not scientists, but we worked very closely with scientists and energy policy experts to develop this presentation. And it has been vetted by climate experts at Duke, at Rutgers, at Princeton, at Tufts, and at Yale. Now, one of the groups that we follow very closely is the Yale Program for Climate Change Communication. And about 4 years ago, they came out with a presentation that said that Americans across the spectrum have 5 major questions on climate change. And we decided to use those 5 questions to structure this presentation. So what are these questions that most Americans have? Well, the first one is, how do we know it's real? The second, how do we know it's us? The third, what do the scientists think? The fourth, is it dangerous? And the fifth, is there hope? So let's jump into that first question. How do we know that climate change is really happening? Well, for one thing, because we understand the basic physics of how greenhouse gases work, and it has been well understood for over 150 years. Let's jump to science class. Here we have the sun putting out its solar radiance, coming through the atmosphere and striking the planet. Some of that solar radiance is absorbed by the planet, but quite a lot ricochets back out towards space. And when it does so, it is at a different wavelength. And this new wavelength is captured by a minute portion of our atmosphere, less than 1%, that is made up of greenhouse gases, primarily carbon dioxide, nitrous oxide, methane, and water vapor. And it is literally their three-atom structure that enables them to capture this ricocheting energy and then re-radiate it back towards the Earth. Without them, we would have a frozen planet. But when we add to them, it simply means they capture more of that ricocheting energy and re-radiate more back to our surface, warming us up and adding energy into our climate systems. Another way to look at it is looking at the carbon dioxide cycle. We all know that there is a balance between plants and animals with carbon dioxide, but we may not know there's also a balance in where nature stores carbon, in the earth, in the oceans, and in the atmosphere. Let's take a minute to look at these two words, fossil fuels, because if we consider what they are, I think it will help us understand what's happening. Fossil fuels are little bits of plant and animal matter, perhaps a dinosaur that fell to the ground millions of years ago, got silted over, and with time, heat, and pressure, got turned back into pools of carbon. And man came along and said, really portable, really rich in energy? I'm going to use it. I'm going to use it in my transportation, to heat my homes, to power my factory, and to run my economy. And life was good. But in doing so, man was unwittingly taking carbon that nature had sequestered, who pulled out of the system deep underground, and started pumping it up into the atmosphere at the alarmingly fast rate of 40 billion tons of carbon every single year. That's much faster than what occurs in nature. And at the same time as we're doing that, we're cutting down our trees and marginalizing our wetlands and our meadows. And that means we were adding even more carbon up into the atmosphere and making it harder for nature to rebalance. And how are we doing that? Primarily by putting up emissions from fossil fuels in the transportation and electricity sectors, a little less so in industry, commercial, and agriculture. Though I should note that if we were looking on a global level, agriculture and land use makes about 25% of emissions. So hopefully you're with me on the basic science. Let's move into how we know how much is happening. And one way we know how much is happening is because scientists can measure it. They are measuring it at almost every single day, from the top of the atmosphere down into the oceans and all around the planet at over 10,000 sites. And on top of that, they add satellite information. Now you can imagine all that raw data is hard to create a big picture from, but luckily for us, there are many agencies in the world who are responsible for doing just that, such as the Met Hadley Center over in England, NOAA, NASA, the European Center for Medium-Range Weather Forecasts, and the Japanese Meteorological Agency. And again, taking all that raw data and independently analyzing, they all come up with the exact same big picture. And that is that we have increased the temperature since pre-industrial times by about 1 degree Celsius. Now, 1 degree Celsius correlates with 1.8 degrees Fahrenheit. And that probably sounds like a pretty good idea on a cold winter's day. But in fact, small changes in our average global temperature make for big changes on how we experience life on the surface. We'll get more into that as we go into the presentation, but don't let the small numbers fool you. Now, scientists aren't just measuring it, they are also observing it, and we can too. Let's take a look at climate change in action with our own eyes. What we are looking at here is the Arctic Ocean. And in this depiction from NOAA, we see that the mature ice is depicted in white. And we can see it melting and leaching away and being replaced by immature ice and open water, which is reflected in dark blue and light blue. And as you can see in this image, which starts in 1990 and comes up towards current time, we are losing vast amounts of that mature ice. And the reason that is so important is the fact that it is highly reflective, which means that when that initial solar radiance comes in, more of it ricochets back out into space. It is almost like a windshield screen that we put up to keep our cars cooler. What scientists tell us is we've lost that screen, locking in increased temperatures as we go forward. It's also important because now Russia has ice-free borders for much of the year, leading to all sorts of geopolitical ramifications. And our Navy now has an entire new ocean to patrol, which has all sorts of budgetary ramifications. But ice isn't just on the water, it is also on land. Take a look at these pictures of the Muir Glacier in Alaska, taken at the exact same place, exact same time of year, about 60 years apart. It looks like they're from two different planets, right? And this is happening all around the world. In our own Glacier National Park, when it was founded in 1910, there were 150 large glaciers. Today, there are a handful, and they're all expected to melt away by 2030. So we'll have to come up with a new name for our Glacier National Park. So scientists are measuring it and observing it, but they have another way of explaining how they know climate change is happening. And that is by looking into the past to see how today is different than yesteryear. That is through a discipline called paleoclimatology. Paleoclimatologists study proxies, things like ancient ice, ancient trees, seabeds and lake beds, and ancient corals. And perhaps the ice is the most intriguing because these ice cores can go back 800,000 years. And scientists like this one are looking for tiny little air pockets that were captured when snow fell and froze over. And they can liberate those air pockets to discern what the carbon levels were way back in time. And what do the paleoclimatologists tell us? They tell us that humans have never been on the planet when carbon levels were this high. Let's take a closer look. As we go back 800,000 years, you can see that our carbon dioxide levels bandied between 150 and 300 parts per million. These were through the natural cycles the Earth has always gone through ice age and thaw. And then you see in 1910, we broke out of the natural cycles and crossed over 300 parts per million. In 2018, we hit 409 parts per million. And scientists say if we continue on our current emissions path, we will hit 1,000 parts per million by the end of this century. And because we know that carbon dioxide and temperature always move in lockstep, and we know that carbon dioxide can last in the atmosphere over 1,000 years, it means that the carbon we put out today will impact generations out as far as we can envision. So hopefully you're with me that climate change is real. Let's move to our second question. How do we know it's us? Well, scientists have another discipline to help us understand our influence, and that is the discipline called atmospheric chemistry. Atmospheric chemists can literally measure the molecules in the atmosphere that come from burning fossil fuels because they have a different isotope, a different atomic thumbprint, if you will. Another way that scientists know that we're the ones driving the change is that when they put into the models all of the things that naturally affect the climate. Things like the Earth's orbit, its wobble, its tilt, volcanic activity, and solar radiance. You get this bright blue line, which shows that if the Earth was left to her own devices, we would be in a slight cooling period right now. But when scientists add in our activity on top of the natural activity, we get the bright green line. And look how closely that approximates the orange line, which is what has been observed and actually happened. So we cannot explain what's going on without factoring in our influence. And because if nature on her own accord would be colder, you could say that man is 100% responsible for heating up the Earth. Let's move to the third question. What do scientists think? And this is a gateway question because only about 20% of Americans understand how strong the consensus is. In fact, the consensus is as strong as our understanding that smoking cigarettes leads to higher incidence of lung cancer, something I think all of us in this room would accept. Now, I know there are a lot of numbers bandied out there, but we went to a source that we found very credible, NASA. And on their website, they say that 97% or more of climate scientists say that climate change is happening and man-influenced. You don't get that kind of consensus in science. But perhaps you're somebody who doesn't believe in individual scientists. But let's think about some of the more prestigious scientific associations, shall we? Would you agree with me that the National Academies of Science is one of the most credible associations out there? Yes? Well, 14 years ago, when George W. Bush was president and there was no pressure on scientists to say that climate change was happening, all of the National Academies of Sciences of the leading countries of the world came together to issue a warning. And they wrote, "The scientific understanding of climate change is now sufficiently clear to justify nations taking prompt action." 14 years ago. And if you don't value the National Academies of Sciences, take a look at any association you find credible. I did for all of these, and it was unanimous. Climate change is happening, it's man-influenced, and poses risks ahead. And if you don't believe the scientists, take a look at what the fossil fuel companies are saying. Exxon, the risk of climate change is clear and the risk warrants action. Shell, we recognize the significance of climate change. A key role for Shell is to find ways to provide much more energy with less carbon dioxide. And even the Oil and Gas Climate Initiative, which is made up of the CEOs of the biggest oil companies in the world, say they agree with the Paris Accord goals and recognize the urgency to address climate change. So if the CEOs of Saudi Aramco, Exxon, Shell, Chevron, and BP agree that climate change is happening and poses an urgent threat, what are the rest of us arguing about? Now, I'd like to take a minute and ask you to think about how you normally evaluate risk in your life. If you're like most of us, we divide it into three pieces. The first piece is, how likely is it to happen? Well, we just saw the Arctic Ocean melting away with our own eyes, and we just saw that NASA says 97% or more of climate scientists are saying it's happening. So I think we can check that box. The second part of the risk assessment normally is, so what are the consequences if it comes to pass? Can I live with them, or are they things that I really want to avoid? And the third part of that risk assessment normally is, how difficult or expensive is it to avoid that risk? Would you guys agree? Yeah. So let's jump into that second part of the risk assessment. What could the consequences be? And are we comfortable living with them if they indeed come to pass? And to do that, we need to move to our next question. Is it dangerous? Now, I'd like to take a moment to orient you to this slide because I believe this is the most important slide in the presentation because it shows the big picture. So on the x-axis, we have time from today back 20,000 years. On the y-axis, we have temperature in Fahrenheit, so it's quick for us to read. The yellow line is average global temperature, and the white are more or less milestones to give us reference points. So as you can see, 20,000 years ago, we were in the middle of an ice age. There was a mile of ice above Manhattan, the southernmost glacier, ended just north of my hometown of Princeton. Much of the earth was uninhabitable. But over about 10,000 years, nature moderated, and the temperature rose to what has been the average global temperature more or less for the last 10,000 years, 60 degrees Fahrenheit. And once we arrived there, we had the emergence of agriculture. This little bump is when Mesopotamia flourished. This little hill, perhaps a full degree, is when the Vikings were able to grow vegetables in Greenland during the medieval warming period. This divot, perhaps a degree and a half, was the little ice age that caused such deprivation and food shortages and upheaval. And then we see the temperature going up, up and away, landing somewhere between 3.6 and 10.8 degrees Fahrenheit by the end of this century, depending on what we choose to do. So let's think about that. 8,000 years for nature to moderate, to literally march trees from Mexico to Montana to create the ecosystems and the biodiversity that we depend on. 10,000 years of remarkable stability. And then man, through our activities, are triggering potentially that same delta in temperature in 100 years. That's scary, right? And that is what brought all the countries of the world together to say, we can't go there. We need to keep the temperature at the 3.6 level, which correlates to the 2 degrees Celsius we read about in the press, or even better at the 1.5 degrees Celsius goal, because we think at those levels we can mitigate, we can adapt, and we can be okay. But above that, we aren't so sure. So let's take a look at what these natural systems are that are being changed by climate change. But as we do so, I'd like you to evaluate these changes through 3 specific lenses. And the first one is, how will these changes affect the economy and jobs in your area? The second is, how will they impact health and personal security? And the last is, how will they impact your exposure to geopolitical instability, which we experience as civil chaos, refugee flows, and terrorism? Anybody in the audience want to take a guess as why I'm asking you to look through these 3 lenses? Anybody? Because these are the 3 things that Americans say are most important to them when they vote. And we believe that climate change will negatively and profoundly impact all 3. Let's see if you agree. Let's take a quick look at temperature. This graphic from NASA shows how global average temperature has changed from pre-industrial times to today. When it is blue, it is colder than average, white average, yellow warmer, red hotter. So as you can see, at the end, the red really comes crescendoing in. And that's because we aren't just breaking records, we're really shattering them. As you can see from this graphic, the 5 hottest years on record globally have been the last 5. And we just experienced the hottest June ever recorded. But that's looking backwards. What's happening on the ground today? Well, for one thing, our friends down in Australia had to add the color purple to their national heat map because they are routinely forecasting temperatures above 125 degrees Fahrenheit. But what does it mean for us in the future? Well, Climate Central, which is a nonpartisan scientific group, took a look at what summers in New York could be like if we continue on our current path. And they averaged 26 different models to do so, not just taking the worst case scenario. And what we see is that if we continue to emit carbon the way we have, our summers in New York will be 9.5 degrees hotter and feel like summers in Lehigh Acres, Florida by the end of this century. Another thing that Climate Central looks at is danger days. And danger days are days when the heat and humidity hit 105 degrees Fahrenheit. And that's a critical point because it's there that we can no longer sweat to cool off our bodies and it becomes dangerous to be outside. We've all experienced that recently when we heard of the excessive heat warnings just this past summer. It's an important time because municipalities have to set up cooling centers, and it means that we cannot be outside for recreation or for work. They are lost days. Well, in the New York region, we don't experience that very often today, but looking forward, it is projected that we could have up to 17 days in about a decade and a full month by mid-century if we continue on our current path. As sobering as that is, it's even more alarming as we look to some of our favorite cities in the South. This is a chart of cities who are projected to have nearly half a year of danger days. if we continue on our current path by mid-century in 2050. And you can see it's some of our very favorite cities. It's Naples, it's Miami, it's Orlando, it's Austin. So let's take a moment to think about those three lenses. How do you think their economy and their jobs will be impacted when they cannot be outside safely for almost 6 months of the year? Well, we know that productivity goes down as heat goes up. We know that crop yields go down as heat goes up. We know they will need more infrastructure to keep their population safe. And we know that infrastructure degrades more quickly at those heats, so we'll need to invest more in infrastructure. So clear hit to economy and jobs. What about that second lens, personal health and security? Well, we know that heat exacerbates lung and heart disease. We also know that crime goes up as heat goes up. But what we may not know is heat is the #1 weather killer. So clear hits against our personal health and security. But what about that third lens, our exposure to geopolitical instability? What could scientists mean about that? Well, what they say is that as hot as it will be in the southern states in our own country, it could be much hotter and much less habitable further south. And they envision people leaving those countries and coming up against our borders in a refugee flow unlike any we've ever experienced. So heat alone causes damages across all of those three categories. But of course, heat isn't just in our country, it's all over the world. Take a look at this graphic from NASA that shows heat projections if we continue on our current path at the end of the century. And what they project is that heavily populated areas like Northern Africa and the Middle East could average over 113 degrees Fahrenheit. That is the cool of the night averaged in with the heat of the day, which means that the Earth never has a chance to cool down, which is so deadly to so many species. And if you think that the Syrian refugee crisis was caused by 5 million people being displaced, imagine the refugee flows coming into Europe when vast swaths of highly populated areas are no longer as habitable. Let's move off of heat and move quickly to food. This is from the Non-partisan World Resource Institute. And you can see everything depicted in red shows crop losses at a 3 degrees Celsius increase. The green shows crop increase in yield, but you can see it's primarily in Russia and Canada, which are not our heavily populated areas of the Earth. And if you go up to 4 degrees or 5 degrees Celsius, there's no green left on the map. But food isn't just on land, it's also in the oceans. And many of us don't realize that when carbon dioxide mixes with ocean water, it turns into carbonic acid. And that's really bad news if you are a creature who makes your shell out of calcium. Many of the things we love to eat, like mussels and clams, but even more importantly, these little critters which are at the base of the marine food chain and very important to salmon and mackerel and other fish that we depend on. These little tetrapods are already showing damage from the ocean acidity today, which is about 30% more acidic than it was in pre-industrial times. And when you put these specimens into water as acidic as is projected on our current path by end of century, they entirely melt away. We aren't just acidifying the oceans, we're also heating them up. From this graphic from Climate Central, we can see that in some areas we've already hit 4 degrees warmer. And that has real implication for our hurricanes. It's changing the patterns of our hurricanes. Scientists are still trying to figure out exactly what will happen, but that makes sense because hurricanes are nature's way of cooling down her oceans. And the heat has another deadly impact, and that is it is bleaching our coral reefs. And our coral reefs are nurseries to 25% of all marine sea life. So clearly, we are hampering future generations' ability to feed themselves from the sea. And I'd like to take a moment to think about those small numbers for a minute. In the most recent International Panel of Climate Change report last fall, scientists said that if we keep the temperature increase to 1.5 degrees Celsius, we could potentially save 10 to 30% of our coral reefs. But if we go to 2 degrees Celsius, they expect we will lose them all. So every smidgen of a degree matters. Every little bit is worth fighting for. Let's stay on water and move to this heavy rain flood. Anyone want to guess where this occurred? No? So it could have been Texas. It could be Louisiana. It could have been Washington, D.C., Charleston, West Virginia. It's New Jersey. But the reason it could be almost anywhere is because these heavy downpours are happening more often. And they're happening more often simply because of physics. Warmer air holds more water vapor. Every degree Celsius the temperature rises in the atmosphere, it holds 7% more water. So where are these heavy rainpours happening the most? Well, in the New England Northeast area primarily, and secondarily here in the Midwest. And while we may be getting too much rain on occasion, we are also getting too little snow. Precipitation is falling as rain longer into the year, and snowpacks are smaller and melting earlier in the year. Clearly, this has ramifications for cities and farms that depend on that snow melt for their water during the hot growing seasons. Let's stay on water and move quickly to sea level rise. Sea level rise is one of the most bedeviling impacts of climate change because we know we have set it into motion and we know we have quite a bit coming, but what we don't know is how fast it will arrive. So how do we know that it's coming? Well, because we saw those glaciers melt and that water is moving from the land into the sea, and we saw that the oceans are warming, which means that it is thermally expanding. So between those two things, the ocean has risen about 9 inches since 1900. Now, the best case scenario that we have heard is that the oceans could continue to rise to 1.5 to 3 feet by the end of this century. Worst case scenario is that it could rise 8 to 12 feet, depending on how unstable the ice shelves are in Greenland and in Antarctica. And remember, it doesn't stop at 2100. It will continue past that. Now, clearly that has ramifications for our economy. We looked for a non-green source, which is Zillow, to get a sense of what sort of property losses we could be looking at. And according to Zillow, at a 6-foot sea level rise, we would have about $900 billion worth of property underwater. And you can see that Florida would be the most exposed and New Jersey comes in second. You really need to drill down to the city level to really see what the impact could mean. In Boston, that means that about 18% of their real estate would be underwater. In Miami, it is 30%. And of course, it's not just our cities, it's our infrastructure, it's our roads and bridges, our airports, our railroads, and our fuel depots. All of that will have to move or be protected. And the costs really are almost unfathomable. So perhaps you're someone who doesn't believe in projections. Then take a look with your own eyes at climate change in action up and down towns along our coast. And all of these towns, they are experiencing sunny day nuisance flooding on a regular occurring basis. And it doesn't look so dramatic, but if you're a business trying to stay open, it's really hard for your customers to get in. If you're a homeowner, it's really hard for you to sell your house or get property insurance, and you have to move your car every time it floods. And it means that school buses can't come through to pick up your children. So real hardship that we are seeing right now due to climate change. Let's quickly move to health. This is for the Centers for Disease Control, which has a very robust site on how climate change will impact our health. And on it, you'll see a lot of things that you would guess, things like drowning or shortage, but there are a couple of things that really struck me as being out of what I would have anticipated. One of them being asthma. And that is because asthma is triggered often by pollen, and pollen levels are increasing as carbon dioxide goes up. And this has real implications for our public health budgets. The other thing that is increasing as carbon goes up are woody vines like poison ivy. It's becoming more toxic and growing more rapidly. And another thing that is increasing as well is the summer-like conditions leading to more rampant and more deadly wildfires. Now, clearly, management of forests plays a part, but scientists say that because the summer-like conditions extend so much further through the year, when a fire starts, it burns more quickly and it causes more damage. Another thing that is expanding are disease vectors, things like mosquitoes, ticks, and fleas. They are expanding their geographical area and they are active longer through the year. This means there are more days that they can bite us and we can become ill. In New York City, you can see that there are 15 more mosquito days since 1980. And Centers for Disease Control also says that climate change will impact mass population movement and international conflict. What does the CDC mean about that? Well, what they mean is that when you take these pressures and put it on places with weak governance and poor institutions, it can lead to chaos. But it's not just the CDC who says so. Our own U.S. Department of Defense, in a report to Congress, has written, "Climate change is an urgent and growing threat to our national security, contributing to increased natural disasters, refugee flows, and conflicts over basic resources such as food and water. These impacts are already occurring, and the scope, scale, and intensity of these impacts are projected to increase over time." And it's not just our U.S. Department of Defense. The former Director of National Intelligence agreed. Dan Coats, the former Republican senator for Indiana, wrote in his report to Congress, "The impacts of the long-term trends towards a warming climate, more air pollution, biodiversity loss, and water scarcity are likely to fuel economic and social discontent and possibly upheaval through 2019. And I would be remiss if I didn't talk about the loss of biodiversity. Many of you may have a beautiful place like this near you. This is a reservoir where I like to walk my dog. Nearby, there's a farm stand where I can buy a crisp apple. I hope that one day, if I ever have grandkids, I can bring them here as well. But scientists say that my grandkids may not experience this beautiful splendor because these trees need the cold to flourish and they are moving north. And this is happening around our country where we are losing our most sacred spaces. And I don't know how to put a price tag on that. To me, it's really priceless. And all of these changes are impacting our GDP. Taking a look ahead, according to BlackRock, we see significant drop in GDP through most of the country as we head into the second half of this century. So let's take a moment to think about what I just shared with you. I shared with you things that have been measured, things that we could see with our own eyes, and some projections from groups like NASA, who we normally look to keep us safe. Are those projections spot on? Of course not. They're just projections. And so much of it depends on what we choose to do. But the question isn't whether they are 100% right, it's whether they are credible. Because anywhere else in our lives, when there is a credible risk and the consequences are this dire, we would take action to avoid that risk. How many of you have fire insurance for your homes? Yes? Just about everyone, right? Is that because we're 100% sure that our house is going to burn down? No. But we take precautions because if it does, it's catastrophic. We buy the insurance, we close our fire doors, we're smart with our appliances. Scientists say that the risk of climate change negatively impacting us is much greater than the chance of our house burning down. Yet we are not evaluating it the way we do other risks in our lives. Now, I know there's some pundits out there who say, don't get alarmed, don't get sucked in. Those models, they're way overblown. But what they don't tell us is about all the scientists on the other side of the equation who say the models are underreporting the risks because they don't include the black swan events, things that are less likely to happen but truly catastrophic if they do. Like what? like the melting of the Arctic. We all know that up in the permafrost, many organisms froze before they're fully decayed. But now the Arctic is heating up more than any other area of the planet. And those creatures, those organisms, are decaying en masse, putting up methane and carbon dioxide. Scientists worry that could become a feedback loop that man could never counter. So we have the scientists who say, hey, don't worry, be happy. We have the scientists who say, drink heavily, the Titanic could be going down. And we have the vast majority of the scientists in the middle saying, this is a real risk, and we can do smart things to lessen that risk. And we're supposed to choose and take a bet. And we have to realize that bet isn't just for us, but for every other person on this planet, and for our kids and our grandkids and future generations. What would a prudent person choose to do? So I can see I've depressed you. So let's move on to the fifth question. Is there hope? Because Sea Change Conversation believes resoundingly, yes, indeed, there is hope. And the reason there is hope is because the economic equation about this issue has been turned on its head. We all know the old economic equation, right? Climate change is going to impact far-off generations and far-off places. It's much more important to protect the economy now and keep it strong and let them worry about it if it comes to pass then. The new equation is climate change is happening now and we are paying for it as taxpayers right now. And the cost of mitigating that risk by moving to a lower carbon economy has dropped so precipitously, it is insane not to move in that direction. So what do I mean? What do I mean that we are paying for climate change as taxpayers today? Well, we are paying to prepare for what nature is throwing at us and repair from what she just threw at us. How are we preparing? A $14.5 billion wall to protect the southern flank of Louisiana. Texas asked for $60 billion to protect its shoreline. Miami just spent about $700 million to raise up its roads and increase its drainage to keep the sea at bay for a little longer. The Corps of Engineers say they need $2.8 billion to protect Norfolk and the port. New York City is considering a $25 billion seawall. Real dollars. And as I said, as we are preparing for what's coming, we are also paying for what just hit us. This graphic comes directly from Dr. Peter Höppe, who is the climate expert over at Munich Re, the leading reinsurance company of the world. And he gave us a slide and said that not every single bar on this chart that shows these loss incidences rising dramatically are due to climate change, right? We've always had loss. We've always had disasters. But what Dr. Höppe said, and the scientists concur, is that climate change stacks the deck and loads the dice. It makes these types of loss events more likely to occur and often much more deadly and more expensive when they do. And when you think that in 2017 we spent over $300 billion on natural disasters, that's 3 times what we spend on public education in this country. So it's real dollars, and it's projected to increase as we go forward in time. And at the same time as we're paying as taxpayers already, the cost of moving to a low-carbon economy has dropped so precipitously. As you can see from this chart from Lazard, today the cheapest new form of power generation is wind, and the second is solar, and the third is natural gas, followed by coal, and followed by nuclear. That is a game changer. And what that means is in places like Georgia, where they don't talk a lot about climate change, renewables are now going to make up 20% of their energy mix, simply due to economics. And in Texas, on a windy December day in 2018, they got 55% of their electricity from wind. Or Colorado, which just issued a report that they could save $2.4 billion if they move more quickly to renewables by 2040. Or even Oklahoma, which announced that they are moving to a solar plus wind plus battery unit instead of building a gas peaker plant. So on economics alone, we're moving in the direction of a lower carbon economy. And we know we could do so much more. Our own National Renewable Energy Lab said that we could meet 80% of our electricity needs by renewables alone by 2050. And with that change and transition, jobs are being created. From this graphic with information from the Department of Energy, we can see that almost 3/4 of all jobs in the power generation sector now come from non-fossil fuels. The number 1 and 2 fastest growing jobs are in wind and solar. Again, a game changer. And it's not just in this country. I think we were all used to thinking of China as being the largest emitter and kind of the country to be most worried about in this area. But if you look at it, China has decided that they are going to be the leader in the new low carbon economy. And they are outspending us 2 to 1. And they have about 30% of the new patents while we have only 15%. Again, they want to own the new low carbon economy. And it's not just China. From this graphic, we can see that developing countries are taking the lead and beginning to invest more in renewables than even the developed countries. And this is critical because these economies are growing so fast and their populations are expanding, and their energy needs will grow into the future. If they can leapfrog over the technologies of the past directly to low carbon technologies, we all win. And they did that with telecommunications. They jumped over the poles and wires directly to wireless, and we need to help them make a similar transition. And in our own country, we know what to do. There are policies that work that fit in a conservative agenda, and a middle agenda, or in a more liberal one. This one, the carbon tax and rebate, is the proposal that James Baker, Hank Paulson, and George Shultz have been traveling the country saying is the way to address climate change using conservative principles. But we need to make a choice. Where will we invest our dollars? Will we continue to invest in the fuels of the past, or do we pivot, as much of the world is doing, to invest in the fuels of the future? As has been noted, we didn't leave the Stone Age because we ran out of stones, but because we found something better. And while at the federal level we are perhaps dithering, others are rushing in this country to pick up that mantle of leadership. Cities, states, universities, businesses are leading the way. And they're not doing it because they're good guys. They're doing it because they see that climate change will impact their businesses and their entities directly. Don't take my word for it. Take a look at what General Mills has to say. As a global food company, General Mills recognizes the risks that climate change presents to humanity, our environment, and our livelihoods. Changes in climate not only affect global food security, but also impact General Mills' raw material supply, which, in turn, affects our ability to deliver quality, finished product to our consumers, and ultimately, value to our shareholders. And it's not just General Mills. This is a smattering of the companies who were at the Paris Accord saying they also agreed with those goals. And we know what we need. We need more investment, more innovation. And we know that great wealth and opportunity will come to those who are the innovators and the disruptors. The experts say that this revolution happening in the energy sector will dwarf the one that hit the telecommunications sector in the early 1990s. What do we need to invest in? Energy efficiency. It is the low-hanging fruit where we can save money and save emissions at the same time, and one that other countries are doing much better than we are. An interesting point is that when the Empire State Building was retrofitted, it paid back for itself in 3 years. Pretty amazing, right? We also need to modernize and decarbonize our grid. We have the new technologies to do so. But we need to move quickly in making the grid more nimble and flexible so that we can integrate higher levels of renewable resources. And as we do so, we need to also increase our ability to store energy. And I show you this little personal battery. It could also be in your own electric car, but these batteries enable us to help the utility system. because it means that at a peak period, they could borrow 1% of the energy in each of our batteries instead of turning on a fossil fuel peaking plant. Once we decarbonize the grid, we need to electrify everything we can get our hands on, whether it's our cars, our buses, our garbage trucks, even our airplanes, as well as heat pumps and our heating and cooling. But we know we need to use fossil fuels as we make this transition. And to do so safely, we have to find a way to capture that carbon. This is a prototypical plant up in Iceland where they capture the carbon dioxide, put it down under basalt rock, and when water trickles down, it turns back into rock. This is a negative emissions plant in Switzerland, which actually sucks carbon out of the air, captures it, and sells it to a nearby Coca-Cola plant to add fizz to our drinks. But think about this. If we can capture it from the air, we may no longer have to take it from the earth, right? And I'd be remiss if I didn't talk about nuclear, because new nuclear is coming that's much safer, much more flexible and nimble than what we've had in the past. And in many countries are moving ahead in building these safer units. Often they use salt instead of water, and they shut down on the basis of physics instead of needing human intervention. And fusion is potentially finally within reach. Scientists say that new breakthroughs in computing and in lasers and in electromagnetic fields are enabling them to make major strides in moving towards this clean, abundant, and safe form of energy. And we need to think out of the box. This is a solar road in France that helps power a nearby village. But as I said, the Chinese are trying to do one better. And in their solar road, they put little electrodes so that an electric car could drive over and self-charge as it drives down the road. And I'd be remiss if I didn't talk about the innovation needed in the way we use our land, in our agriculture, and our farming, and in our forestry. Scientists say that if we move to mimic nature, to use processes that would help sequester the carbon, we could actually absorb a third of the carbon, the excess carbon in our atmosphere. But we are in a race, and right now we are losing that race. As you can see from this chart, which is in Celsius, we are on a path of about 6 to 10 degrees hotter at the end of this century. So let's think about that. At 7 degrees colder, we were in an ice age. At 7 to 10 degrees hotter, what do we think it will be like? We don't want to find out. And to do that, we need to come together. We need our scientists and our engineers and our technology specialists to come together with our entrepreneurs and our financiers and our investors and our corporations, and we need public support and policy support. And the exciting thing is there is so much movement up here. There is so much exciting breakthroughs going on in these 4 sectors. But where we fall down is with public acceptance and will and policy at our national level. And that's what all of us can help with. So I'm sure you're asking, what can you do? Well, the first thing we need to do is to care. We need to understand that every time we look into a stroller and meet a new young child, that we are looking at the face of someone who is going to be on this earth when she is playing by very different rules. And we need to understand that child is going to grow up and look at us and ask us, what did you do? What did you do to try to stop this? We also need to get energized. So many people say, oh, it's so overwhelming, there's nothing we can do. If a foreign country was coming in to take as much land away from us as we are losing to sea level rise and constant drought, we would be at war. If an asteroid was coming at the mid-century that would hurt our abilities to have clean water and fresh water and food, we would have the scientists scrambling to find a way to protect us. Right? We are not taking this risk seriously. Don't be intimidated. There are about 20% of the American population who say they do not believe in climate change. That's about the same as say that we never landed on the moon. 72% say they are concerned. Yet who is driving the policy on a national basis? Because we are not letting it be known that this is an issue we care about. Influence your policy leaders. And this is important no matter what side of the aisle you sit on. Democrats have given lip service to this issue for a while, but they haven't done much on it because, quite honestly, you get elected and re-elected by handling short-term issues, not delving into deep, complicated, long-term ones. And on the other side, we have heard from many credible sources, Governor Christie Whitman, the head of risk strategy at Goldman Sachs, that many legislators on the Republican side see the science and understand the dangers. But what they say is they cannot move because they will be primaried and lose their job because their constituents do not support this issue. So whatever part of the aisle you sit on, please raise your voice. Vote. We need both parties engaged on this. We need candidates across the aisles coming up with the fresh ideas. Get educated. There's so many great resources out there. If you want to know more, find us after this talk and take personal action. There are many things that we can do as individuals. One of the first is to take care of nature, to ameliorate our wetlands and our meadows and to plant trees. We can also lessen our personal footprints in our homes by getting an energy audit and installing LED lighting, energy-smart appliances, solar, or geothermal. And if we can't do that, look to see if you can buy renewable energy directly through your utility, because you can in about half of the country. Reduce your waste. We waste about 40% of our food. And if you think about the energy involved in the growing, storing, and transportation, it is just mind-boggling that we throw that away. Eat locally and consider a more plant-based diet. Look to buy electric cars. They are one of the quickest way to lower your footprints. Also look for hybrids or using public transportation. Buy carbon offsets when you fly. Influences company. Use your influence with companies, whether as an employee or as a shareholder or an employer. And also support not-for-profits. There are ones active in the conservative arena, the middle, and on the liberal side. So in closing, I'd like to say that scientists have said we are the first generation to fully understand the risk of climate change. And we are the last generation that can do anything about it to lessen the risk so the brunt doesn't fall upon our kids and our grandkids. And the question for all of us in this room and all of us on this planet is, what will we choose to do? For more information, or if you would like us to come to your community, please reach out to us at our website, seachangeconversations.org.